A/B testing is everywhere, but not all results actually mean something. That's where statistical significance comes in. When a result is statistically significant, it means it's unlikely to be caused by random noise, and all the more likely to reflect a real useful trend. But how do we determine that? It all comes down to three key concepts: hypothesis testing, the normal distribution, and p-values. Statistical hypothesis testing is something we do all the time, even if we don't call it that. You start with an idea. This is called the alternative hypothesis, and test it against the opposite assumption, which is called the null hypothesis. Think of it like hearing water outside and wondering if it's raining. Your alternative hypothesis is that it's raining, while your null hypothesis is that it's not. If you look outside and see the rain, you reject the null hypothesis. In more complex experiments, stating your hypotheses clearly prevents you from fooling yourself into believing a result that isn't actually there. To understand significance, you also need to know about the normal distribution, also known as the bell curve. It's a way of modeling data where most values cluster around the average, or mean. The steepness of the curve is determined by standard deviation. If data points are close to the mean, the curve is narrow. If they're spread out, the curve is wider. This distribution helps in determining how surprising or extreme a result is. Then there's the p-value, which tells you the probability of seeing a result as extreme as yours, assuming the null hypothesis is true. Before running an experiment, the significance level should be decided, commonly set at 0.05. If the p-value from an experiment is smaller than this threshold, the result is considered statistically significant. A p-value of 0.05 means that if you were to reject the null hypothesis, there is only a 5% chance that this turns out to be a false positive. If you want an even higher confidence, you can set a stricter threshold like 0.01, which would mean that there is only a 1% chance that you incorrectly rejected the null hypothesis. Let's say you suspect a coin is weighed towards heads. Your null hypothesis says it's a fair coin. You decide that if you get a p-value below 0.05, you'll reject that null hypothesis. You flip the coin 10 times, and it lands on heads 9 times. The p-value for that result is 0.01, which is below your threshold, meaning you have significant evidence that the coin is weighted. Even in more complex experiments, the actual math is straightforward. Most statistical significance tests can be run in a few lines of Python or R. The key is not just running the numbers, but understanding what they actually mean. If this gave you a better grasp of statistical significance, hit the like button and subscribe for more insights on data-driven decision making. See you next time.